2.6 Special Functions. In this lesson, we're going to focus on two types of functions: piecewise defined functions and absolute value. So first, let's talk about piecewise function. A piecewise function is exactly what it sounds like. It's a function broken into pieces. So right here, you have one part of a function, you have another part, and another part. The way we write a function like this is we break it down like this. So here's our function. We'll say f equals, a little curly bracket, and then we have to write what this part is. So like this looks like it, let's say 5. Then we say if, you have to say what values it's between. In this case, let's just say x is between -3 and -5. Then you say the middle part, which is looks like a -x² type of graph. If x is between these values, like -3 and 1.5, and then you do the final part, just so like negative signs of slope there. -x plus 8, let's just say. If x is between 1.5 and 5-ish. So since that effect, so like you can look at it and go, okay, I'm 5 from right there. I'm -x² plus 2 from right here. And I'm this equation from right there. That's what a piecewise function looks like. So let's talk about two things to do here. First, we haven't talked about domain and range yet. We'll talk about that in a couple of sections, so we're going to ignore that for now. Let's talk about how to find values, and we'll talk about how to graph this. So first, let's talk about how to, if I want to find a value of this. If I say, what is f of 3? Now the way this works, you only get one answer. So what you want to look at is these things right there. Which ones 3 follow? Is it less than 0 or greater than 0? What's greater than 0? So you just plug it into this equation there, which is just 3. And if I ask you what is f of -5, you're like, well, -5, is that less than 0 or greater than 0? It's less than 0, so you can plug it into this equation. -5 plus 2, which is just -3. And what if I ask you f of 0? Well, you just see which one it qualifies for. Less than 0 or less greater than equal to 0? Well, it's equal to 0, so it's this one. So it's just 0. So that's how you find a value. That's how you evaluate a function when it's piecewise. You just look at this, where does it fall? Does it fall in this graph or this equation? And plug it in. Now if you want to graph it, I kind of do it this way. So let's graph this one first, x plus 2. So what I like to do is make it dotted. So we're going to graph x plus 2. So y-intercept with 2. And then the slope of 1 over 1. So I'm going to go up 1 over 1. So my graph's going to look kind of like this. Now the only part of the graph I want is where it's less than 0. So that's my x. So here's my x. Here's 0, where I'm less than it, where I'm to the left of it, right? Less than means like this way. It's supposed to be an arrow. I want the left side. And then notice how there's no equal to sign, so it should be an open circle. It's my open circle. And I only want this part of it. So I'm going to fill this part up. So only part of the graph I want is this part. I don't need that. You can leave it dotted or you can erase it. It doesn't matter to me. So if you want to look a little nicer, you can erase that. There we go. Now we're going to graph this one, x. Now the easiest way to graph x is just add a plus 0 there. So, oh, my y-intercept is 0. Slope is 1 over 1. So we're going to go up 1 over 1. Do a dotted line. Not the best, but I try. And if x is greater than or equal to 0. So same idea. Here's equal to 0. And you want greater than, right? You want to the right of it. So I want this side of it. So this is the part I want to fill in. I wish I could draw straighter, but I can't. There you go. And that's my piecewise function. Let me erase this so it's a little bit nicer. Right? And there he goes. I want this graph when it's less than 0, so you just graph the whole thing. Then you want the less than 0 part. You want this graph when it's greater than 0. And there we go. Let's do another one. Now before we do it, let's do another practice of how to evaluate. I'm going to pick let's find f of 1. Right, f of 1. Where does the 1 fall? It falls right here. So f of 1 is just going to be 1. How about, let's do a tougher one. F of 7. F of 7 falls right here. Well, there's nothing to plug into, so you just get -3. That's the way it works. When there's no x, you just get the number. So it's -3. Everything bigger than 2 is to be -3. So again, that's how you evaluate. You just look at where does it fall and plug it in. Now let's graph this thing. So I'm going to graph this one first. 2x plus 2. So start at 2. Slope of 2 over 1. Slope 2 over 1. I'm going to do a little dotted line. Now I only want less than -6. So here's my x. Here's -6. Notice it's an open circle, no equal to sign. So like that. And I want less than, I want to the left of it. So I want this side. All that I don't want. I can erase or leave it dotted, doesn't matter. I'll leave it dotted this time. Now let's graph the middle one, x. Remember the easiest way to graph x is just add a plus 0. So we're starting at 0. And I have a slope of 1 over 1. So I'm going to go up 1 over 1. Dotted line. Oh, I can never get that straight. And in this case, I want between -6 and 2. So at -6, I want a closed circle, because that's what it is. Closed circle right there, equal to sign. And at 2, I want a closed circle. Now I want in between those two. So I'm just going to fill this in. Try my best. Okay, that's okay. Oof, that's bad. That's what I want, right in between those two values. And then lastly, the last one's the easiest one. -3 if x greater than 2. So -3, that's y equals -3. You just go -3 on your y. Follow the tally mark. So it looks like this. And all I want is greater than 2. So at 2, put an open circle. Remember, you want greater than, you want to the right of it. So this right here. And that's my piecewise graph. Again, it looks a little prettier if you just erase all the stuff you don't want. Like, I don't want any of this. I don't need this, that, or that. Right, see? That's my piecewise graph. Notice there's like a part for every graph, right? You're kind of partitioned right here. Like this is where you divide it. There's one graph on this side, one graph in the middle. Right, there should never be more than one graph on either part. Otherwise, it wouldn't be a function. It wouldn't pass the vertical line test. So that's our piecewise graph. Now let's go backward. Now they're going to give us a graph. We have to come up with any equations for it. So the way we're always going to start at the top is by writing f of x or g of x, whatever. That little bracket, and then we're going to have one equation for each little partition. So we're going to have one for that one, middle one, and the right one. If. So right, so this graph's like broken down into 3 pieces. So we got to first find this. Let's find this one right here. Let's find this equation there. And the way we do that is the way we always find equations. If we want to find an equation of a line, we're going to do y minus y1 equals mx minus x1. Or you could do y equals mx plus b. In that case, you need the y-intercept and the slope. I don't really know what the y-intercept is, so I'm going to have to do this one for now. Right? To do that one, I need 2 things. I need a point and I need a slope. So for a point, always find one that's nice. So I'm going to say at this point right there. Negative, oh, it sucks. It counts by 2, so -6, 0. So -6 is my point. I need my slope, so I got to find another point that crosses nicely. I guess this one is what they want it to be. It looks like -3, -1. I hate that. I hate their grid. Anyway, so we got to find a slope. Easiest thing to do is just rise over run. Right? I went down 1 and I went over 3. Down 1 over 3. So my slope here is going to be -1/3, and my point is -6, 0. If you simplify that, because I need to plug it in, so I need to simplify in this case. I'm going to get y minus 0 equals -1/3 x plus 6. Distribute, and I get y equals -1/3 x minus 2. Yeah, -1/3 times 6 is -2. So that's this part right here. -1/3 x minus 2. Now for my right here, my part, it looks like it's only less than -3. So when x is less than and equal to, because it's a closed circle, -3. Alright, so we're going to find the equation like we always do, and you just got to figure out when does it value. It has value when it's less than -3. Now the middle one's the easier one. It's a y equals, it's 2, y equals 2, right? It's just going a straight line, so it's y equals 2. And it happens between -3 and it looks like 1. So x is between -3 and 1. No line right here because they're open circles. And then the final one right here, just like the first one, we gotta find the equation of that, so we gotta find 2 points. So here is 1 point, and the other point, I'm gonna say this, I guess that right there. I really hate the grid they use. That looks like 2 and 7. And this one right here is 1 and 3. So, gotta find the slope. Riser runs the easiest, so it's 1, and I went from 3 to 7, so 4. So let's write my equation down here. Y minus y1 equals m x minus x1. So that's 1, 3. I went over 1 to get to 4 to 2, and then I went up 4. So my slope is just gonna be 4 over 1, or just 4. Then I plug any point I want for x and y. So it's 2, 7. I can see clearly. So we have that. And now I do have to simplify, so I got to put in a slope intercept. I want to put it in here. So y minus 7 equals 4 x minus 8 plus 7 plus 7. I get y equals 4x minus 1. And then if, this is when y is greater than 1. X is greater than 1, sorry. And that's the idea. Right, you gotta break it apart, do this equation first, just like we always do. Find equation, the way you find equation line, right? Point slope form. Middle one, do a line, and then that one. Let's do this one real quick, because this will be faster. But just make sure we got the idea. So I'm gonna write my function. I'll do g of x this time. I need 3, because there's 3 different graphs I see here. I need when's the active. So this first one, the one down here. Right, so this is an easy one. It's a straight line, so this y equals whatever the line is, -8. So y equals -8. And it's only good when x is less than, right, going to the left, -6. And less than equal to because it's a closed circle. Now before I go on to this one right here, I'm gonna do this one right there, because that's another easy one. Y equals 4. And then when it's x is greater than 6. This time no line because it's an open circle. So all I gotta do now is the middle one. Right, there's 2 ways to do the middle one. You could do y minus y1 equals m x minus x1. Find a slope, find a point, plug it in. Or you could do this. And this time I'm gonna do this one because I actually have the y-intercept. It's 2. That makes that one easy. All I gotta do is find the slope. So you find 2 points and find the slope. So in this case, I ran over 4 and you went up 1. So 1/4. So 1/4 x plus 2. Right, again, if you have the y-intercept, that's the fastest way to find the equation of a line. Now, f, you're between what? -4 and 4. So x is between -4 and 4. Done. Right, so that's how you go backwards. Just figure out the equation for each one, plug it into the little system right there. So that's piecewise functions. A lot of people tend to have a hard time with piecewise functions. And just graph each one separately. Okay, now let's quickly talk about absolute value function. So as we talked about before, absolute value is a distance formula. It's always positive. That's why it's always positive. So anytime you put absolute value on something, it makes it positive. So that's what's going on here. If you think about your normal y equals x, the graph looks like this. Right? But now, if you put absolute values around that, what happens is, this part's okay, that's positive. This part's negative though, so what happens? We make it positive. So you get that V going. So that's what a basic absolute value graph looks like. Looks like a V. And that's why, because absolute value makes stuff positive. Just for a little bonus right here. Absolute value does that to everything. If I say, hey, here's f of x, and I said f of x was, let's say, this graph, and I went like, hey, what's the absolute value of that? What you do is you go, okay, this part's positive, that part's good. That part's bad, it's negative, so what you do is you make it positive. You get that? That's what absolute value does. Make stuff positive. Let's do one more real quick of this type. we'll do a graph that looks like this. That's my g of x graph. Now if I want to take the absolute value of this, that part's okay. I gotta make it positive. That part's okay. Gotta make this part positive. That part's okay. Make that part positive. Right, so that's what an absolute value does to a graph. It makes it positive. Now let's go back to what we were talking about though. The very basic, the normal absolute value graph, this one right here, it makes y equals x positive. Right, so it makes that. Hence we get this v there. So now again, we're going to ignore domain and range. Let's talk about what this stuff does. So general is this. If there's something on the outside of absolute value graph, we'll talk about more about this next time. That makes it go up and down. It moves your graph up and down. So if I gave you y equals absolute value of x minus 4, you take the normal absolute value graph you have, and you move it down 4. And just draw it again. This is called a transformation, and we're gonna focus more on it next lesson, but for now it's a little intro. So I have this graph, and when we draw the absolute value of x plus 2, I'm just gonna go up 2, then draw my absolute value graph. It's supposed to be a v. There we go. So something like that. We're just doing a quick sketch, but that's what it does to it. So anything on the outside moves it up and down. How about if it's on the inside? Now this one's a little funkier. So when something's on the inside of absolute value graph, that moves it left and right. But here's a rub. It moves it the opposite direction. So if I give you, for example, if I give you y equals x plus 3, what you want to think about this is it's a negative 3. So we're going to move it left 3 because negatives are on the left hand side. So my graph would be 1, 2, 3. And then you just grab your absolute value graph. So for this one right here, it's the last thing we're doing today. If I want to graph this, it's on the inside, so you want to treat it like a positive 5. So we're going to move to the right 5 right here, then draw a v. Again, we'll talk more about transformations in the next lesson. It's a little intro. There we go.